Hi everyone, my name is Francesco Meggetto. I'm a PhD candidate at the University of Strathclyde in Glasgow, UK. In this talk, I'm going to present our short paper on skipping behavior types in music streaming sessions. This presentation is based on the submitted version of the paper later accepted at CIKM 2021. This work has been done at the New Research Lab in collaboration with Professor Crawford Revy, Dr. John Levine, and Dr. Yashar Mushfeghi. The ability to skip music is nowadays a core feature in modern online streaming services, and arguably it has changed the way users interact with the platforms, for example on Amazon, Apple, or Spotify. The skip is a signal that can be considered as an implicit type of feedback that can measure user satisfaction or dissatisfaction or lack of interest. And in turn, this can affect their engagement with those platforms. Existing works have mostly focused on analyzing the skipping patterns as a function of the time at which this takes place between a song. This is what is referred to as the skip profile in the literature. However, understanding skipping behavior is still largely underexplored. In this work, we try to answer the following 4 research questions. The first one is, what are the main types of skipping behavior that we can identify at a session level? Then, for having identified these types, we now try to understand the interplay with the, for example, weekday and weekend day types and how they affect their overall distribution, or different times of the day, morning, afternoon, evening, and night. And lastly, the playlist types, for example, personalized playlists, radio, charts, catalog, etc. This paper has the following 3 contributions. The first one is that it is an extensive investigation on user skipping behavior during entire listening sessions. We then identify 4 main types of session skipping behavior, which I'm going to discuss very shortly. And lastly, it is an investigation on the influence that various listening contexts have on the distribution of these patterns. Our approach can be divided into 2 phases. The first phase is data transformation, and this is what we refer to as a session skipping pattern extraction. In the dataset that we've used, we have 4 skip features, namely the skip 1, skip 2, skip 3, and not skipped. And they represent some thresholds on when the skip happens during a session. By analyzing their interplay at record level, we identify the following 5 patterns. For example, true, 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 false, etc., up until false, 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 true. This last one, what it means is that a user played a song in all of its entirety. Then, for each of these patterns, we associate them with an ID integer, a scalar representation, which is a value from 1 to 5. And this represents the skipping activity for every record of a session. Having that, we can now construct a session-level vector representation. And it is the order sequence by session position of all individual skipping activities that form a session. In this example here, we have a sessions of length 20, and it consists of 1, 1, 2, 1, 5, 3, etc. What this means is that this user played the first 2 songs very, very briefly. Then he did a very briefly for the third song, a very, very briefly again for the fourth, followed by all for the fifth, and then a briefly, etc., etc. Now, for the second part of our approach is what we call the session skipping type identification. So from this set of session skipping patterns, we apply principal component analysis, PCA, and we do so by returning 70% of the explained variance. Then we apply k-means plus clustering with Euclidean distance for the type identification. Finally, we also perform a local evaluation to find the optimal number of both the PCA components and also clusters. In the case of clusters, we tested in the range 2 to 40. The dataset that was used in this experiment is the Spotify Music Streaming Sessions dataset, MSSD, in short, released in 2019. It is a real-world and large collection of 150 million logged streaming sessions, where sessions are defined as being sequences of songs or tracks that contain from 10 up to at most 20 records. It's important to note that our analysis is performed on the entire training set. To answer our research questions, we have identified the following contextual scenarios: weekdays and weekends, time of the day, playlist type, and all. The time of the day meaning that we have the night 0 to 5, the morning 6 to 11, the afternoon 12 to 17, and finally the evening, which is 18 to 23, meaning the 6 p.m. until the 11 p.m. The all type of analysis is the one that is performed on all available streaming sessions. Lastly, by retaining 70% of the explained variance, as I just mentioned, we identified 7 PCA components for long sessions. Those are sessions of length 20, 6 components for the medium ones of length 15, and 5 for the short ones of length 10. We then identified 4 to be the optimal number of clusters. Now for the results discussion, this first part is about the skipping types. Here on the right, we have box plots for, at the top, long sessions, those of length 20, medium sessions at the center of length 15, and then at the bottom, we have the short ones of length 10. Each box plot is plotted against the session position on the x-axis, which is, of course, 1 to 10 for short, 1 to 15 for medium, and 1 to 20 for long. And then on the y-axis, we have the skipping pattern, the ID value from 1 to 5, which I mentioned earlier on in this presentation. And then we have 4 columns, which represent the 4 clusters, and we name them to be the listener type, the listen then skip, skip then listen, and skipper type. What we observe by analyzing the different lengths is that types have no strong relation with the absolute length of a session, and thus form some sort of generalizable behavior. What this means is that the shape of the listener type for long sessions is highly similar to the one we can find in medium sessions, and it is also highly similar to the one we find in short sessions. Also, at a closer look, we actually observe 2 pairs of complementary behaviors. Meaning, for example, the listener is a complementary behavior, is a skipper, and the listen then skip is with a skip then listen. Now, onto the second part of our results discussion is about distribution differences. So here on the right, we have a chart with the long sessions at the top, medium sessions at the center, and short sessions at the bottom again, and distribution from 0 to 100%. And we have the 4 columns, which represent the 4 types. We have the listener in light green, light blue, we have the listen then skip, dark blue, we have the skip then listen, and finally we have in light orange the skipper type. To answer our second research question, the weekdays and weekends, what we see is that there are no significant differences among them. And this is attributed to the global user distribution of the Spotify's dataset, and also the cultural differences on the definition of weekend. What this means is that a Western type of weekend is different from, for example, an Islamic one. And therefore, this makes the weekdays and weekends the type of scenario a weak definition. Now, moving on to the third research question, the times of the day, therefore morning, afternoon, evening, and night. What we see is that as we progress through the day, there is an increase of the skipper activity. Here in long sessions, from a 39 in the morning, we reach a 43 in the evening, meaning that in the evening, there is a higher skipping activity than what we find in the morning, for example. In the morning, there is a higher listening activity. For the fourth research question, we have the playlist types. So editorial playlist, user collection, catalog, radio, charts, and personalized playlist. And in here, we see significant differences among them. For example, the catalog has consistently one of the lowest skipper activity. And this is due to users having higher control in the music selection process, and therefore they have there is a higher listener activity. Also, what we see is that the listen then skip, which is identified in light blue, has always a higher activity than its counterpart, the skip and listen in dark blue. Finally, when we look at the distributions for different lengths, what we see is that as sessions become shorter, there is a decrease of the skipper type, and therefore an increase of the other types. When we reach the short sessions now, we have now the listener in green being the most prevalent type, which is in opposition to when we started with the long sessions where the skipper was the most prevalent type. What this means is that now in short sessions, those of length 10, people tend to listen more and skip less. In conclusion, the aim of this work is to identify different behaviors during entire listening sessions with regards to the user session-based skipping activity. We propose an effective data transformation and clustering-based technique, and we are now able to identify 4 main dominant skipping types, namely the listener, listen and skip and listen and skipper, 2 pairs of complementary behaviors, the listener with the skipper and listen and skip with the skip and listen. And also that their distribution, the distribution of these types varies sometimes significantly under different listening context information, as well as session length. For future work, we hope our findings to inspire future research in better understanding and modeling music skipping behavior. Thank you for listening. And if you have any questions, please quickly reach out via email at francesco.meggetto@strap.ac.uk. Thank you very much.